All right, this is the second section of Chapter 9. We're going to continue on with our radical stuff, radical and exponential conversions. This section is a little longer than the first one, and it really takes all the exponential rules into play here. So I'll cover them as we need them instead of throwing them all at you all at once. Okay? All right, so if we're evaluating an exponential, let's do this two different ways. Let's use the rule that a radical can be converted into an exponential in this form or vice versa. You can either go this way or you can go that way. So if I have 16, that's over here, to the 1/2 power, that's the same as, well, my n is a 1 and that goes here. Okay? And my index is 2. Well, I don't want to write it this way, right? That's just this. We don't ever want to write the first power, and we don't ever want to write a square root with the index of a 2 showing, so this will be 4. Okay? Well, what else can we do to verify that? Well, we can take the original and we can raise it to, with the parentheses, the 1/2 power. Okay? This is really what it's saying, though. And sometimes our calculators aren't going to help us. It depends on the numbers. Sometimes the numbers are too large, it can't convert for you. So you have to be careful that you do know how to do these by hand as well. All right? And then when we get into x's and y's and z's, obviously we can't use the calculator. So, all right. So 16 to the 1/4 power, okay, if we would rewrite that to the 1/4 power using this rule here, that's the same as 16 to the 1st power to the 4th root, which is really just the 4th root of 16. The 4th root of 16 is, I think, 2. 2 times 2 times 2 times 2. Okay? So even though this is correct as far as these are the same, it's not the most simplified form. So when we're looking for these and it says the simplified form, it's the most simplified that you can get. So that would be the 2. Okay? So don't fall into that trap. Sometimes people get all excited about multiple choice questions, but I tell you what, if they're done correctly, they're going to be difficult because you've got these two right here that you could easily say, oh, it's just that. So you have to be careful. All right, so here we're looking for the cube root of -64. We can also just use our calculator. -64 in parentheses raised to another parentheses of 1 divided by 3. All right, so it's -4. And again, this, don't get caught into this because these are equivalent, but it's not the most simplified form. Let's see if our calculator can do that one. I don't know. That one probably can be done. So we want the cube root of, 343. I just lost my train of thought there. Don't you hate that? I do. Gosh. Raised to the 4th power. 2401. These are all radical forms. This is the most simplified form. I think this is the one that you can't use your calculator on. Oh, there's a bunch of them down here. All right, let's just see what happens. I think the numbers are too large. 256 raised to the -3 divided by 4 power. No, maybe not. 1/64. Okay, this one works. 1/64. Now, if they don't work, because when I previewed this just earlier, my original one didn't work. Oops. So you'd have to do these by hand. So just be careful. Okay. All right. So now what we want is our exponential to radical conversion. Well, we have it right here. Okay. They just want us to write it as a radical. Well, that's really easy, isn't it? If I have 2 to the 1/3 power, I'm using this form and going into that form, so that would be the cube root of 2, right? Because we really have a 1 there, but we don't write the 1, so that's the cube root of 2. And I don't think it wants you to evaluate it, it just wants you to rewrite it as a radical. Okay, so this is your nth root, so you can put the 3 in there, and then your radicand of a 2. All right, this is the same thing, except the directions are kind of goofy. It says write with radicals. Okay, so we can. Okay, so let's see what we've got going on here. 7 to the 5/6 power is 7 to the 5/6 power, right? 7 to the 5th and the 6th. Now, why is that wrong? Let's see if it'll take it. So we have 7 raised to the 5th power, and it's not going to like it. It's not in the correct form. Well, that's because of these goofy directions. It says use the definition that takes the root first. Well, if I was looking at this, the way it's written here, I would take the power first and then take the root. But it wants it the other way around. So what it wants is the 7th root of 6, and that's all raised to the 5th power, like that. These are identical. Because we can either take 7 to the 5th power and then take the root, or we can take the root and then raise it to the 5th power. It doesn't matter. So it wants this, I don't know if I can do this here, and then we want to raise it to the 5th power. See how that 5 went on the outside? That's what it wants. So be careful in those directions, okay? Don't throw it underneath, even though these are definitely equivalent. It wants that on the outside. All right? What happened to my... Oh. There it is. All right, so rewrite with radicals. Yikes. All right. Let's not even look at the answers, shall we? Let's just do it, because you don't know whether or not you're going to get a multiple choice on the test or not. So 3e, all raised to the 2/3 power, minus 7q raised to the 4/7 power. Okay, we want to write these with radicals. Okay, so here's my radicand on this one, right? I've got a 3e underneath there. And this whole thing is raised to the 2nd power and the cube root. And I'm not sure, you could put that inside too. We'll see what the multiple choice gives us. I'm going to match my sign here. And here I've got my radicand of 7q. I've got the 4th power here and the 7th root there. So let's see if any of those match. Looks like this. Yep, that one. Right there. Cube root of 3e raised to the 2nd power. We got it on the outside. Minus the 7th root of 7q raised to the 4th power. So whether I have these things in parentheses or not doesn't really matter. That's also the same, okay, as what I had. So we'll choose answer A. Fantastic. All right. What about negatives? What about them? What about them, Simone? We have a rule here that says, let's say A, that if you switch the level, it becomes positive, or this way. Okay, we've seen that before. All right. So really, we've got a negative exponent. We're just going to throw that thing underneath. Okay, so really we're just going to switch the level that it's on. 3m cubed plus 2k cubed to the positive 2/5 power now. What are we doing here? We're supposed to rewrite it with radicals. All right. How would you write with radicals? That sounds like a little kindergartner. How would you do this problem? Okay, so that has to stay in the denominator. Okay, we've got our radicand, that doesn't change. Let me just copy that down, right? My root is 5. I'm taking all this to the second power. Let's see if one of those match. Let me just lift that up just a bit. Okay, so we have 1 over 1 over. Okay, so it's not that one, obviously. This one's goofed up because these are backwards, so we're going to look to these here. Looks like that one, doesn't it? The 5th root of the radicand raised to the second power. See, it's always C. Nice work. All right. I don't know. There's 23 points in here. I'm going to do most of these because they're all so different. It's really hard to just do a few of these and then you get to these other ones and you're like, well, what about that one? You know, they're all so different. So, all right, so we're supposed to simplify this. So we have the square root of x to the 4th. Rewrite that as a radical. I mean, as an exponential. Isn't that? 4 halves? 4 halves is a fraction that can be reduced to 2. So the answer should be the square root of, what is it? No, not the square root, it's just x squared. X squared. Fantastic. Okay. All right, let's get into our exponential rules. More rules, more rules, more rules. X to the a times x to the b. Now, if the base is the same, a plus b, right? We add exponents. So let's see what we got going on here. We've got k to the 7th root and the square root of k, and these are multiplied. So what we'll do first is we'll rewrite these as exponentials. Okay, these have, now put in the pieces that you need that aren't there, but really are there, and convert to the 1/7 power times, this is to the 1/2 power, right? 1/2 power. Now I've got a base of k, and I've got multiplication, so I can add my exponents. 1/7 plus 1/2. Well, how do you want to do it? Do you want to do by hand? Do you want to use a calculator? I don't know. We have an LCD of 14, right? So this would be 2/14. Turning that into 14ths, just like I did on those expressions. Here I've got 7/14. So this is the same as 2/14 plus 7/14, which is equal to k to the 9/14. Now if we didn't want to use our brain because we were feeling lazy, we take a 7th and we're going to add a 1/2. It's okay. You know what, as long as you, hang on, I can't do two things at once. As long as you understand how to do it by hand, we don't have to do everything by hand. All right? It's when we don't understand how to do it by hand at all and we rely on the calculator for everything. That's when I have an issue with it. A real issue with it. Okay, so this is telling us to use our exponential to radical notation to get it back into a radical. All right, so I have to change this back. Okay, so I have, what do I have? I have k to the 9th to the 14th. Is this multiple choice? It's not. All right, so I have a 14th root, and I have k. Let's see if it'll take it underneath there this time. It didn't give us the directions that we had to do the radical first, so we can throw it underneath if we want. We could also put it on the outside if we wanted to. Okay, so what we did here is we converted first of all to exponential form, then we used our exponential rules, that multiplication is addition, and then we changed it back into a radical. Okay, same thing here. We need another rule though. We have to have the rule that involves division. If my base is the same, then I take my top number minus my bottom number. So division is subtraction, multiplication is addition. Okay, so you're going to go about this about the same way. You're going to take your radicals. We're going to change them over to an exponential because I don't have any rules with radicals here. I have all kinds of rules with exponentials. And then we're going to convert it back. All right? So this is the same as x to the 3/5 and x to the 3/6, which is the same as x to the 3/5 over x to the 1/2. Anytime that I want, I can reduce down. Using my rule, that would be x to the 3/5 minus 1/2. I have a similar base. I've got division, so that indicates subtraction. And again, I'm going to, because I know how, I'm going to be lazy. Not use my brain. That's okay, we'll save it for other stuff. Right? A 1/10. Let's just make sure it wants it. Does it want it? Yep, radical. All right, so now we go back to the radical form of the 10th root of x. There really is a 1 there, but we don't need that. Okay? So if I was to put a number in here and do all this, or if I just did this, it'd come out to be the same answer. So we have the 10th root of x. Good job. All right. Well, what about something like this? You have multiplication, but you also have a negative. Does it matter which way you go first? No, not really. Almost not at all. Okay, so what I could do is I could make that positive first and then divide. I'm just going to choose to leave it alone for right now and combine those with addition, right? Adding a negative is like subtracting. So we have 11/16 minus, how many sixteenths is what, quarter? Well, it's 4/16, right? 11/16 minus 4/16 is 7/16. And we're supposed to leave it alone as an exponent. Okay? The only thing that you have to remember is that it's got to be positive. All right? It has to be a positive. So we have a raised to a fraction. What is it? 7/16 to the 7/16 power. Okay? Did you see what I did there? I put my a in, then I raised it to a fraction and just filled in the blue bubbles. All right, we need another rule. Darn rules, huh? It's like a game. If you know the rules of the game, you can play it. But if you don't, then you're in trouble. All right, my next rule, and these should all be review, is powers raised to powers. Okay, so if you have a power raised to another power, it indicates multiplication. All right, so we're going to use that in combination with, let's just get them all on here right now. That in combination with, I'll just keep all the letters the same. that in combination with this. Okay, those are my basic rules there. Powers of powers is multiplication, multiplication is addition, division is subtraction, and we can always switch the level for negatives. All right, so let's start. We have x to the 1/4 power, y to the 3/7 power, and that's all raised to the 28th power. And then we have an x cubed underneath here, which has nothing to do with this 28th power. Okay, that would be if the parentheses came way down, then it would. But this 28 does not affect this 3 directly. All right, so I have powers raised to other powers, so that's multiplication times 28, y to the 3/7 times 28, and that's all over x cubed. Well, 1/4 of 28 is 7, and 3/7 of 28 is 12, I believe. But you can use your calculator if you'd like. You can do 3/7 times 28 is 12. Okay, 1/4 times 28, 7. I can do those pretty quickly in my head though, which is kind of nice. That comes from years of doing them by hand, by the way. When I was in school, in my undergrad work, we couldn't use calculators at all. So all through my training for 4 years, I couldn't use a calculator. So we never had the graphers. And now I'm showing my age, but we couldn't. We'd come into a calculus final with our pencil and our ID, and that was all we had. So, all right, now I'm going to isolate my bases here. Things have changed, and we've got like bases, and I'm going to use this rule here. I've got division. So I take my top number minus my bottom number. Now this is a different base, so I can't do anything with that. 7 minus 3 is 4. And I'm done. Simplified, yep. Do I have all positive exponents? Yes, I do. So I'm done. X to the 4th. Should we check that one? I'm not going to check all of these. Whoops. Let's put my number in there first, my base. I'm not going to check all of these, but I should check a few. Just so that, but you guys, you know how to put these in by now. So, all right. Same thing here. We've got powers and powers, and then we have division. All right. So I'm not going to do all of these. What I would suggest on this one is to do your powers of powers first. Okay. So you have what, 8/5 here, and you have 16/5, and then subtract. And then if it's negative, well then change the level it's on. These should go fairly quickly. Maybe we should do that one. That one looks like a mess. Good Lord. P to the 1/7, P to the 9/14. I don't think it's as bad as it looks. P to the 1/2 over P to the 12th raised to the negative 1/7 power. Someone's at my door. I'll be right back. Okay, sorry I'm back. Don't know where I left off. You probably do, just because it was a millisecond in your time, but I was gone for 10-15 minutes there, so you can just pause the video and start again. I think I referred this to as a mess. I think that's the last thing I said, and it kind of is. But here we have multiplication. And here we have powers raised to powers. So let's just do them separately for right now. So remember, multiplication is what? Addition. So we're going to take 1/7 plus 9/14 plus 1/2. Those would be really easy to turn into 14ths if I wanted to. Do it by hand. And this one here is powers of powers. So I've got negative 12/7. So that's multiplication. This is addition. All right, so let's do 1/7 plus 9/14 plus 1/2. Math, enter, enter. We have 9/7 on that. P to the 9/7 over P to the negative 12/7. Okay, one rule that I didn't write on here was the reverse of this one, that if I have a negative underneath, it jumps up to the positive on the top. So that's what I'll do here. So I have P to the 9/7 here times P to the 12/7 becomes positive. Okay, so this negative jumps up to that level, becomes a positive. Now we have 9/7 plus 12/7, right? Okay, because now I have multiplication. And I have, what do I have? 21/7, right? 9/7 and 12/7 is 21/7, which is P cubed. Wow, all that just for a P cubed. Let's see if it's right. P cubed. Excellent. Who is that? Is that Smithers on Simpsons? Excellent. All right, I don't need to do this one, but you know, everything is raised to the -2 power, right? Every single one of these things. Okay, so you're multiplying all the powers times the -2, the power times the -2, the power, not the base, times the -2. These will all become positives. Then you're going to subtract your Q's, subtract your P's. This stays down. Okay? I think that one's all right. I'm not going to do every single one of these. This one's just slightly different. We have the distributive law here that we can use. All right, so we can multiply and multiply. When we multiply, we add, right? So I'm just going to do this one at a time. That's your first term. Your second term is, what is that? I don't know. X to the 4/3 times x to the 3/5. Right? This times this minus this times that. Well, like I said, this is multiplication, so we have addition, 4/3 plus 3/5. All right. This one's really easy. This is x to the 9/3. Right? 4/3 and 5/3 is 9/3. Here we have to have a common denominator of 15ths. So this one I'll just do by hand just because I feel like it. So we're going to build these up into 15ths. That goes in there 5 times. 5 times 4 is 20 15ths. And 3/5 into 15ths would be 9 15ths. So here we have 29 15ths. Right? 20 15ths plus 9 15ths is 29 15ths. Okay, this is a 3. 9 divided by 3 is 3. And we can't do anything with the 29 15ths, I don't believe. You can always check that out. 29 15ths. Math, enter, enter. Nope. Stays at 29 15ths. Can I subtract these? Do I have any rules about addition, subtraction? Look at my rules. No, I don't. This is about division and multiplication and powers of powers. I don't have any rules. So remember, it's like I can't add an x squared and an x cubed, can I? They have to be exactly the same. I can add, however, 2x cubes plus 3x cubes for 5x cubes. That I can do. But these don't have the same power, so I'm finished there. All right? Same thing. Now, remember, when you multiply a positive times a negative and a positive times a negative, right, you're going to be, well, this one's a little different. Yeah, I think we should try this one. This one was slightly, when I did the preview, was slightly different, so I should probably do that one. Okay, we're still distributing. I don't know what emphasis you want to go on that. So we have 2a to the 7/2 times a to the negative 7/2 plus 2a to the 7/2 times a to the negative 3/2. Okay, so that's this times this plus this times that. All right, so we have the 2. Here we have a like base and we're multiplying, so that means what? Addition. Here we have like base, we're multiplying, so what does that mean? Addition. Okay? This is 0. 7/2 minus 7/2. And this is 7/2 minus 3/2 is 4/2. Okay, what is anything to the 0 power? Well, if you don't remember that, because you can't put an a in here, but just pick any other number. 5 raised to the 0 power is 1. 7 raised to the 0 power is 1. Anything raised to the 0 power is 1. So this is 2 times 1 plus 2 times plus 2 to the 2nd power. 4/2 is 2. So this is 2 plus 4. Did I lose an a? I did. I was going to say there's got to be an a left in here. I messed up my a right there. A to a squared. Dang it, I hate when I make mistakes. Ah! Alright, so I dropped my a way back here. So it's really a. Okay, so yeah, now I'm good to go here. So it's 2 plus 2a squared. I think that's right. Why do I make mistakes? Don't you hate when you make mistakes? I better check it. And I probably have to go back and fix it. No, I did fix it. But yeah, I just dropped my a here. I forgot to write it in right there. So, you know, when you obviously you're going to start looking at stuff and going, oh, that doesn't look right. Then, you know, it's terribly important to have steps written out on what you're doing, especially on a test. I mean, how do you correct stuff? How do you go back? Let's just say I didn't pick up the a, and I went back and I said that was the answer was 6. Well, now before I submit for a test, I'm going to go back and I'm going to go, okay, is all of this correct? And then I can say, oh crap, I lost my a right here. So numbering these on a test, like, you know, what number are we on? We're on 19. Okay, so on a test on my paper, I would say number 19, and I would do all this work so that I can go back and I can check it. Okay, it's very important to do that. I don't think this is anything different, really. You know, change those over to exponential notation. I don't think this is different. I don't know if I'm going to do this one for you. All right, we have y to the 13/6 times y to the 1/3. No, I'm not going to do that one. All right, we know that multiplication is addition. You're going to add the fractions, reduce it down if you can. Okay, we're almost done here. Same thing here. I don't know, you know, this is k to the 4/3, k to the 5/3. We have division, which is subtraction. We want to write it in exponential notation with positive exponents. So those are just practice. 2 left. What is this bad boy here? The cube root of the 5th root of x. Yikes. Well, take it one step at a time. Leave that alone. Okay, just convert this right here. What is that? That's the same thing as x to the 1/5 power, right? It's looking a little bit better, isn't it? Now convert this. This is x to the 1/5 power divided by 3, right? It's this over that. Okay, so what is 1/5 divided by 3? Well, let's see what we got going on here. We have 1/5 divided by 3 is the same as 1/5 times the reciprocal, which is a third, right? We can always make that into a 1 on the bottom. This is a 15th. Okay, so this is x to the 1/15th power. Now, does it want it in radical or it wants it in exponential notation? Let's try it. I have no idea if that's right. So I'm going to raise it to a fraction. I'm going to fill in my blue boxes, and we did a great job. And the last one I'm going to let you be, because that one's pretty easy too. We've got 2/7 to the third. That's just picking it up from this spot right here, right? And you're going to do that, and you're going to do that. All right. Well, that's it for 9.2. That was a little longer than 9.1, about twice as long. So we're just going to continue to work with exponentials and radicals and going back and forth between their forms and all that good stuff. So this is 9.2, and I'll see you for 9.3.